Right, so basically you might think, well, why don't we just electrolyze sodium chloride? Well, let's look at the process of the electrolysis of sodium chloride, because basically this is what the industry is doing, but this process is not ideal. So we have different methods to enhance this process and to make it better. So essentially in our electrolyte solution, our brine, we've got sodium ions and chloride ions. Okay, the cathode is where reduction takes place. So we would think that sodium atoms would go to the cathode and be reduced. But as you can see in the diagram, that is not happening. Okay, and why? Well, we learned about it in the last little section. Okay, because at the cathode, the stronger oxidizing agent will be reduced. So like we learned in the previous lesson or video, that the stronger oxidizing agent is reduced. So water, therefore, must be a stronger oxidizing agent than sodium. And if you look at your standard electrode potential table, you will see that water is below sodium. So the reduction equation for water is below the reduction equation for sodium. So that means that water is a stronger oxidizing agent, therefore it will be reduced rather than sodium. So you can see already our process is not as simple. Okay, we can't just get sodium. We're actually getting hydrogen gas here at the cathode. So hydrogen gas will obviously bubble out because it's a gas. Okay, at the anode, the anode is more simple and straightforward. The chloride ions will go to the positive anode. Okay, negative and positive attract, and they will be oxidized, so they will lose electrons and form chlorine gas, which will bubble out. Okay, so this is the reaction that happens at the anode, and this is the reaction that happens at the cathode. But now remember, and the reaction is going to go that way because it is being reduced. So we are taking in electrons. At the anode, the reaction actually goes that way, okay, because the ions are losing electrons and forming chlorine gas. Okay, so that's what happens with the electrolysis of NaCl, and we even did this example in the previous video. But now there's some problems with that. So besides the fact that hydrogen is actually made at the cathode, okay, there's three main problems. So if hydrogen gas comes out the cathode and chlorine gas comes out of the anode, the two gases together, if they were to mix, would be very explosive. So that's problem number one. We can't just make an electrolytic cell like this, because there would be an issue, because hydrogen and chlorine would be very reactive. Hydrogen and chlorine would be very reactive with each other. That's problem number one. Problem number two, if you have this reaction happening at the cathode, you can see that water is being reduced and we are getting hydrogen gas, which is bubbling out, great, but hydroxide ions are forming. Okay, so in this now electrolyte, we're going to have hydroxide ions that are forming. Okay.